Hello everyone. So I won't be here for Saturday. So I've recorded another lecture for you guys. And for today's lecture, we're going to be covering 1D and 2D arrays, inheritance, polymorphism, and abstract classes and interfaces. This is going to be a particularly information dense video. There's going to be a lot of stuff. It's going to be confusing and messy. This is a week that I would love to be there in person with you guys, but I sadly cannot make it as I am 2,000 miles away in Austin, Texas. But let's get started. So let's first start with what is an array? So an array is effectively just a list of objects. That's all it is. So let's start with one. So let's say we wanted to store a list of numbers or an array of numbers. We want integer list. Then what we're going to do is we're going to put the brackets right in front of it like this. This indicates that it's a list. Then we're going to type in numbers or whatever name we want, and then we're going to set it like, hold up. We're going to set it like this. So this is what is called an initializer for arrays. So let's type here 3, 4, 7, 25, 245. Why not? So this is an array. So if we system out print this numbers and we run this, we're going to notice something very interesting. So you would expect it to print out the numbers, right? But no, it does not. That is one aspect about an array, is that because let's say if you right click or if you hold control and then you click on string, a file pops up. If you hold this and right click integer, a file pops up. But you can't do that for an array. There is no array class, so it is considered a primitive, and because it is a primitive, a very special type of primitive, it doesn't have any indication of what is stored inside of it. To access these numbers, you're going to have to use the brackets again and select the index of the number you want. So indexes are pretty much just tell you which place do you want to retrieve it from. Java is a zero indexed language, which means that the indexes start at 0, so you're counting from 0, not 1. Same as Python. One notable exception to this is Lua, which is used for Roblox programming. So if you guys have any experience with that, this is not similar to that for arrays. So let's say I wanted to figure out what the third number was. Would it be number 3? No, that wouldn't make sense, because remember, we're counting from 0. So 0, 1, 2, 3. So when we're trying to get the third number, we're actually supposed to put 2 inside of here. It's counterintuitive, but it makes later programming with more complicated like for loops a lot easier to process, a lot easier to understand as well. So let's run this, and we get 7. Yep, that's the third one, but we have to put 2 in here. A little bit of confusing, but you gotta hang with me. So now that we're done with this, note that we can store any sort of value inside an array. So let's say we want to do a string array of phrases, and that could equal like hello, and then bye. And now if we system out print the first string in phrases, which is 0, not 1, and we run this, you can see we get hello. That's the basic of one-dimensional arrays. So one-dimensional arrays, like, it just goes in one direction. Now, you might have noticed I talked about two-dimensional arrays. What in the world is a two-dimensional array? Well, it's when you put an array inside of an array. So let's do that. Let's say we want to have a 2D array of integers. So integer, then we demark it with that. But that's only a 1D array. If you want to make a two-dimensional array, we put it like that. And we'll write out numbers v2 or like 2D. Now when we initialize it, this is an empty two-dimensional array. Now we put another bracket inside of it, and we can put our first values in there. And then to create another array in the two-dimensional array, we just use a comma. Now this is really confusing to look at, especially when you're getting to larger pre-made arrays. So let's break this down a little bit. So using some interspaces, you can see how this is a two-dimensional array. So you have your first row here, and your second row, and then your first column, second, third, fourth columns. Now, to read from a two-dimensional array, there's two ways you can do this. First, you can retrieve the rows, so numbers to 2D, and if you get the first row, and this is effectively just getting the first row of the two-dimensional array. And let's save that as another array. And I don't know, let's name this row numbers. And that is equal to this. So now we're just taking this row and we're storing it in here. And you can do that for all rows. But the more common use case is getting a singular value, right? So let's call this, I don't know, like a coordinate value. And that'll equal to numbers 2D. And we'll find the number at the coordinates 0, so that's first row, and then 1, so that's the second value. So we would write here 0 for the row, and then 1 for the column. And if we print coordinate value, you could see that once we printed this, we get 3. That sounds about right? First row, second value. Or for in Java's terminology, 0th row, first value. Confusing, I know. But let's look at this now. If we go to numbers 2D, we're going to do some fancy stuff with it. We do this. Hey, there's not that much. There's like nothing we can do except for cloning, which is just copy pasting it. If you take a look at the integer class, right, and we have like an integer, so we can use coordinate value right there. And we do dot. Look at that. Double value, byte value. There's all these different things we can do. A bunch of stuff. So how do we utilize Java's built-in functions to manipulate arrays? Well, pretty self-explanatory, but you can go to the Java util class called arrays, and this is a static class, and look at all these fun functions that we can do, right? Look at that. That's a lot. So let's take a look at some of this. So binary search. What you can do is you can find a certain number. You can find a certain number in an array instead of just iterating through every single value. As list, which means you can take a lot of items. Instead of doing it like this, how we did up here, you can take those values and actually just list them out in this arrays.atList function. So 2,538,973. Just an example, right? But this is how you can do wide manipulations to an array. Now, let's say we don't want to use an array, because if you look here, let's say we want to add a value to the array, for example, right? And we want to do numbers, let's see. So we have 1, 2, 3, 4. So 0, 1, 2 is 3 indexed. Let's say we want to add something to the end. Numbers 4. And we try to set it to 23. Now, when we run this code up here, index 4 out of bounds for length 4. What this effectively tells you is that, hey, you're not allowed to add a number onto the end of that array. And that's because of another inherent property of arrays, which is that arrays are actually immutable. Now, what the hell does immutable mean? Well, immutable means is effectively you cannot change the value. You cannot like add something to it. You can only modify certain parts of the array. So if I were to change this to numbers 3 and I modified 245 to 23, if we run it here, you could see that there's no error. It can handle that perfectly fine because you're only changing it. You're not adding a new value to the end of your array. But let's say you want to do that, right? And that's why our Lord and Savior Java, instead of making this built in, they created a new class called a list. Well, compared to an array, this name is certainly more self-explanatory. So let's do this. So list. Let's say we want a list of integers again. We can make list of integer int list equal to, well, let's leave this blank for now. First thing, red. List cannot be resolved to a type. For our quick fix, we can hold down control, dot, and then hit the import list button. What this does is now we're importing the list. So for a lot of things in Java, including arrays and lists, you actually have to import them because Java doesn't like you using special things. And that's just how it works. Like in Python, where you have import functions, it's the same in Java, except like a lot of the more basic things that you don't have to import for in Python, you have to in Java. So let's take a look at this. List of integer int list is, well, let's take a look. We probably think it's new list of integer. And where do we go from here? I mean, that kind of makes sense, right? What is this? Cannot instantiate. Well, hold up. Let's get the error up first because it's red. Well, the error, I don't know why it's not showing up here, but the error is cannot instantiate list object. Now, why is that the case? I mean, we can do new blank for other objects. Well, let's take a look at list. If you can see here, list states that it's a public abstract interface. Now, we'll cover what this jargon actually means later on in today's lesson. But what effectively this tells you is because it's an interface, you cannot directly use it and create a new object. So let's take a step back and say, now where do we go from here, right? Where do we go from here? That's where implementations come in. So interfaces are all about getting implemented somewhere. So we can see in our code, this is it. But if I right click and click on find all implementations, or hold up, no. Okay, Java's not working with me today, but what I can tell you is that this is implemented in other classes. So now we know this implemented in other classes, we have to find those other classes first of all. But utilizing the internet, you can find out that array list. Whoa, array list, that's crazy. I mean, let's take a look at what array list is. So it's a class that extends the abstract list, so it uses the list, right? You see here? It uses that little list object that we couldn't create before. And if we look in here, yeah, I mean, it has like add. Hold up, let's move down, but it says get, set, add. I mean, that's what we needed, right? That's what we couldn't do with a regular list. So if we look inside here, what you'll notice is that actually, I mean, this is just a wrapper around an array. This is the same thing as an array. What in the world? Why do we have to have an entire new class that just uses the array and makes it fancier? The reason is Java hates you. It wants you to fail. So it makes it harder and harder for you to implement certain things because it wants you to look at this and then cry on the inside. But in all seriousness, the reason that it has it like this is actually because Java practices strict backwards compatibility, which effectively means that they like do very, very little changes to the actual base part of their code. And that's why you'll see ArrayList has packaged java.util instead of just being like built in like how arrays and ints are. So yeah, just think about it like that. Just Java's being Java. But let's take a look here. Array list, great. So now let's look at our int list and see what we can do. So int list dot add, and let's say we want to add a 3, right? And now let's print out that value. So int list dot get our 0 value, right? And now if we do this, we get our 3 back. Great. Now let's take a look at what array list can actually do. So if we do int list dot add, you can see here how it adds the integer. There's some other stuff like remove, which is actually going to be useful. And contains, like if it contains a certain object. As you can see, there's a lot of utility that you can have here compared to the comparatively empty arrays utilities. And this is what most programs will use. You'll avoid the usage of arrays and you'll stick to array lists, or lists in general. So now we've effectively covered the basics of 1D and 2D arrays and lists. However, notice how before we said arrays, the class arrays could be used to like binary search and a bunch of other stuff. We didn't see that binary search in the int list, right? If we do here, I mean, there's no binary search, right? It would be up here because it's alphabetized, but there's nothing there, right? So Java, in their infinite wisdom, instead of having one class to do everything, they created two. So introducing collections. There we go. Collections is effectively a copy-paste of arrays, except it works with lists and other types of lists. So you can see your binary search here, you can see reverse, singleton, a bunch of other stuff here. And so, yeah, if you're trying to do manipulations, if you're trying to find something in a list, remember to use collections instead of arrays because Java wants you to fail. So, now we've covered lists, 1D arrays, and 2D arrays. Now we're going to talk about inheritance and polymorphism and touch back on the previous list class that we were discussing about. Now, let's talk about inheritance and polymorphism. First, what even is inheritance and polymorphism? The names aren't really that self-explanatory, so let's start with the easier one, inheritance. As the name kind of suggests, inheritance is effectively just taking certain things from one class and like without having to copy paste it. So if we take a look back at week 2 shenanigans, we can see that we have our animal class and then we have our cat class. And on week 2, we covered how you could use the animal class and extend it so that you didn't have to copy paste certain classes, right? So that's what inheritance is effectively. Inheritance is just having the ability to use classes as a sort of template for other classes, right? So now what is polymorphism, right? So let's take a look at our week 2 code. And let's copy paste our little animal stuff over here. Control C, and then go back to week 3. Open up some space here, Control V. Now we have our animal stuff, and if we want to run it, we can see that it works, right? Great. Garfield, black cat. Now let's clear out some of this. And let's take a look here. Let's clean up the names as well. Cat A and Cat B. Just for easier name calling. And let's just remove all of this, remove all the bloat. Now, let's take a look at this. Cat, orange cat, and black cat named Cat A and Cat B, right? Let's say we have an object, like, let's put animal down for a second. And we don't know what animal this is going to be. And we'll just leave it like this. We don't set the value of it, or if you want it to be more clear, you could set it to null. Effectively, when you do this to a variable, you're just giving the value null to it. So now we set this with null, and now let's say we want the user to select whether they want a cat or dog to talk, right? So we can take a peek at our week 2 code and see the scanner stuff that we wrote out to get user input, and do the same here. First, let's import the scanner class, control dot, enter, and it imports. Now, let's change this up, right? Let's say, hey, do you want to have a dog or a cat, right? And let's make this D or C as our options. Now, if the input is equal to D, then we're going to set the animal we don't know to a new dog. And we'll name this Doggo, right? Now let's utilize else if here. Else if in dot equals C, then animal we don't know is equal to a new cat. And we'll name this cat. No creative name changes, unless we did for doggo, but a cat nonetheless. Now what we can do is we can do animal we don't know dot talk. Hold up. This is an example of polymorphism. So we have our animal class here, right? But what we can do is we can set this animal class to both a dog or a cat and perform the same action on it. Because the animal class has the talk method, and both the cat and the dog class implement the talk method. So what this effectively means is that this saves us a lot of programming headache where we have situations like this or similar where we don't have to create two variables and have a pain in the ass trying to figure out which one to use later on in the code. We can use polymorphism to do this all for us. So now, if we run this code here, which one do we want, dog or a cat? Well, I'm personally a cat person, so I'll CC. Oh my god, it says meow. It worked. Meow with a cat's name. And now, let's say, hypothetically, I was more of a dog person. Put D, and you get woof. Whoa. Crazy. Interesting. Now, that's the basics of polymorphism. Polymorphism effectively just means, as a recap, is you can utilize a class that is shared between multiple other classes that like extend those classes. And you can utilize that to simplify your code and make it easier to write and read. So we can see another example of this back in the list thing. So list is a subclass of ArrayList here, right? So it like gets implemented, right, as an interface. So what we could do is, and to make the code simpler, let's say we have there could be like 30 or 40 different type of lists, right? Instead of having to memorize every single one of those names or have every single one of those names here, if we just write list, then that makes it a lot easier for us to both read and write the code. Now, let's touch on abstract classes and interfaces. Abstract classes and interfaces, let's talk about them. Now, if we go back to our array list and we look back at the list that we had a lot of issue with previously, we can take a look here at these keywords that we skimmed past. Abstract and interface. What are those? Well, let's do a copy paste of our animal class and let's name this walking. So let's rename this walking and remove the rest of this. Let's say we want to be able to denote if a cat or dog can walk, right? So we write, well, extends walking, right? I mean, we did that for animal and it worked. Well, no, that isn't the case. You see here, syntax token extends permits expected. So maybe we have to use a comma here. More errors. What does it say now? Syntax error on tokens. Record header name expected instead. You don't need to know what that second part means, but what it's telling us is the syntax error, which effectively means we cannot do this. But what if we want to know if it can walk, right? And give it certain functions to do that based on if it's walking or not? Well, we call this an interface. Ba, ba, ba. Interfaces. So what an interface effectively means is you can do public void walk, and then just an example, we can say sorry, I am walking, yay. I mean, that's how we think it would work. Abstract methods do not specify a body. Right. So if we want to implement this interface, we need to utilize something called default. So if we want to write a default implementation as we did in animal, right, with like talk and am I alive, then we have to utilize the default keyword in order to specify that this doesn't have to be implemented. So now we can do implements walking. And now if we go and we do that same thing here, ta-da, now we go here, to week 3, and we scroll down here, and we do black cat dot walk, and we run our code here. Hey, I'm walking is printed out by cat. So that's an example of how you can use interfaces to add extra functions. But let's say, hypothetically, we wanted the dog and cat to do different things when they were walking, but instead of doing what we did previously and just adding the function in here, we wanted to force all other classes. So what we would do is we remove default, so it's no longer the default anymore, and put this like this. So now we have errors in both the dog and cat classes. What does it say? The type dog must implement the inherited abstract method walking.walk. This is pretty self-explanatory. It must implement the abstract method that is previously stated in our interface. So if we just do control dot here for our quick fix menu and we click add implement unimplemented methods, remove the error message that gives us, and we system out I am a dog who is walking. And we control C, control V this to the other class. And we can see and change this to I am a cat who is walking. And let's remove this for more clean code. But now if we control S this and then run the code, we say I am a cat who's walking. And if we did this for the dog, it would be the vice versa. Now, something we can notice here that I did not touch upon on previous videos to remove complexity, but I feel like now you guys are ready for it, is that when we automatically made it do it for us, there was an override, like an override tag that was added automatically. So this is what's called an annotation, and effectively all this does is it'll tell us that, or tell the programmer that, hey, this is an override. This doesn't actually do anything necessarily in the code, but it does make it a lot easier to see whether something is its own unique function or unique method, or is something that is given from a previous class. It's just a way to annotate it, as the name suggests, to make it easier for a programmer, especially a newer one that has no idea what the code base is, to understand what's going on. So now we've covered abstract interfaces as a way to add extra classes, no, sorry, not classes, but extra functions to a class instead of having to extend it, which allows for multiple properties to be placed. Now, let's go back to week 3 and figure out the uses of having an implementation. So if we go back here, right, and if we say, for an example, like an if statement, if animal we don't know implements, or sorry, is instance of, and we put walking dot, just walking actually should work, and then we can run some code based on if it's an instance of walking. So if animal we don't know is an instance of walking, and we'll dot, sorry, walk. Hold up, we're getting an error here. That's not good. The method walk is undefined for the type animal. Now, why is that the case? Well, does animal implement walking, right? So how do we expect the animal we don't know to walk? So what we can do here is just to quickly convert it, we can type walker here. And instead of using animal we don't know, we can use walker and then dot walk on that. So if we click this, notice that it doesn't have any of the other functions animal does. It only has walk because we're turning this into the walking interface, right? It doesn't know, the code doesn't know that it, like, if it's a dog, because in this instance it can be a dog or cat, but the code doesn't actually know whether this walking object is a dog or cat. So it cannot use the methods implemented in animal or the methods implemented in dog and cat at all. So if we do walker.walk and we run our code here, right? So let's just remove that, run it again. Hey, do you want to have a dog or cat? Let's make this a dog. Woof! And it now says, I'm a dog who is walking. So let's highlight why this is useful. If we run this code again and we type in something completely random that isn't a dog or a cat, we don't get an error because it's specifically checking. So in this instance, animal we don't know is actually null because we don't set it to anything, but it's making sure that it can actually call this function by checking if it's an instance of the interface and then calling it. This is a safeguard. That's another way that abstract interfaces can be used. So now let's talk about what are abstract classes. Because if interfaces are effectively just classes but more like malleable and only used for implementation, what is the need for an abstract class? So let's talk about what the hell is an abstract class and why do we need it? What's the point? So let's go back to our walking, right? And let's say we want to have a variable here. Like if we go back to our animal class, notice how we have our string here for the name. Let's say we want to have something similar in walking, and we want to denote whether how many legs it has. So we would put public int legs, right? And notice how, for now, let's ignore the error, but notice how in animal we have our constructor. And let's say, maybe I don't want to look at what the error it's throwing, and I want to create a constructor. So public walking, and we put like that. Hold up. Put like this. Hey, wait a minute. This is erroring. Well, the error is pretty self-explanatory. Interfaces cannot have constructors. So how do we do this? Well, let's look at the beauty of abstract classes. Let's put it here, public abstract class. So we're changing walking from an interface to an abstract class. And if we do public int legs, right, and then we do our constructor here, public walking, and we put our constructor here, and we write, and then we can, like, here as our argument, we can put int legs, and then this dot legs is equal to legs. So it's setting the instance's legs amount to the one that's inputted, right? Now we look at walk. This method requires a body instead of a semicolon. Whoa, whoa, whoa. So what does this mean? Well, effectively, right? Let's take a look at walk. Remember previously where we weren't allowed to have a body and we had to specify with default that it could have like a certain preset amount? In abstract classes, it's the opposite. You have to state that it has no body and it has to be implemented by every class. So if we put here public abstract void walk, notice how it allows us to do it. Now let's go back to dog and cat, see what's going on. Implements walking. What does it mean by this? Well, because it's an abstract class, we lose all the advantages of interfaces, in which we can layer multiple of them on top of each other. Because you have your constructor here and walking, you have to have it as an extends function. So let's put here, extends walking. Are you kidding me? Well, we don't have a talk function anymore, and this isn't an animal anymore. How do we remedy this? Well, let's do the same here in cat and think of a solution, right? I'd say all walking things are animals, right? Or there are certain outside cases where walking things are not animals, but let's presume that that doesn't exist in our lovely Java universe. So let's go to our walking class and see here. Hey, maybe we can do extends and then add animal because it acts like a class, right? It's just an abstract class. Maybe you can do that. Woo! We can. This is great, right? So now we look here, implicit superconstructor is undefined. So now we're going to do super, right? And then name. And now we have to, we have to add our string name into the arguments because we have to set the name of the animal. So now here. And now if we go back to dog, well, first it's erroring here, but we can see why it's erroring. It says this constructor of walking with only a string as its argument is undefined. That makes sense because we need the amount of legs as well, and as our argument. So we can put string name and then int legs, and we can plug in our name and the amount of legs we have. And we can do the same thing for cat, where we'll just take this, paste it in, ta-da! Now let's take a look here and notice how we're getting a bunch of issues because the constructor cat string is unidentified. Let's put 4 here, and let's say cat A is a war veteran and only has 3 legs, sadly. And we have to do the same thing here, so we can do 4 here, and we can do 4 here, because none of these guys fought in the Vietnam War. So now, and we go do the same thing here in week 2 to make sure nothing breaks. So now, if we run our week 3 code, and we have a cat, let's say, wow, meow, a cat who's walking, right? Not only does it implement the walking interface, or actually now it's an abstract class, not only does it implement that, but it is also an animal, which we can use here. So as you've seen in here, interfaces and abstract classes can have all sorts of implementations. Interfaces specifically meant for layering numerous kind of details about a specific class, but you don't need to store variables, right? So you could have a talking interface, a walking interface, right? And you can layer all of these on top of a singular class instead of just having only one with extends. But if you want to add more functionality and kind of meld the worlds of classes and interfaces, you can use an abstract class, which allows you to not implement a certain method and leave it to the non-abstract class to implement. And that's all. This was around the same length as the previous class, but that will be, so it's not too long, but I highly suggest you guys watch a video I'm going to send about inheritance and polymorphism. That is one of the hardest things to get into your head about programming. Super, super difficult to accomplish properly. So this has been Anish. I'm really happy to be teaching you guys Java. I really hope that you guys have learned something from this video. If you guys have any questions, concerns, etc., feel free to message me on Discord, Slack, or my phone number, which I've given out to you guys. Please ask any questions. I will be available during the class as well as after and before. I'm just sadly not able to be there with you because I'm too far away. And I hope to see you guys next week, which will actually be in person, finally. Sorry about that. And have a great day or night or evening or morning or midnight, depending on when you're watching this.